Hi, this is the 11th video in the Test First Development series, and in this one I want to talk about managing change. Now, one of the criticisms of Test First Development is that it creates a lot of overhead that makes it difficult to change your code, that it kind of inhibits an agile approach to updating code and moving quickly and adapting to new requirements. So I want to address this directly. I think there definitely is a point that when you're dealing with a set of code that's well tested, you do have to do the work of updating the tests. If you just let the test library get out of date and languish, then it loses its value very quickly. So that's true. You do have to invest in updating the tests. However, there's a real payoff, and I've seen this happen, where by updating the tests as part of your change process, then you can actually change and refactor more confidently and without so much fear of introducing unexpected or unintended bugs. So it can reduce regressions, really. So I'm going to just take you through a few changes to our coffee shop now, and partly because I want to show you what that process looks like, and also partly because I want to make the app just a little more complicated so that we can talk about some other real-world topics in future videos. So here we go. Let's update our coffee shop a little bit and make it a bit more interesting. So the first thing I want to go over is a simple refactor. This is something we do all the time. So you'll notice we have this function here for getting an open SQL connection. Now, this is the kind of thing that is very likely going to be shared among many code units. And having it buried in here is not the best idea. So what I want to do is extract this out so that later we can make this shared code. So I'm going to start by going to my coffee shop lib, and I'm going to add a class, and I'm going to call this one SQL Helper. And now I can grab the using clause, and this will be a static class. And then I'm going to yank this function out of coffee shop and put it inside of SQL Helper. I haven't changed it at all. I've just reorganized the code. And then I need to go through and find every place where I was needing a connection. And let's just make sure that these all use the new connection. I think that should do it. Let's build that and see if it works. So there you go. That's a code refactor. We haven't changed our interface. We haven't changed any business rules. We shouldn't need to write any new tests. The question is, did we accidentally break our code? Did refactoring that out cause anything to break? Probably not, but probably isn't good enough. Let's prove it. So let's go back and rerun our coffee shop tests. And they all pass. So that gives us a lot of confidence that our code refactor didn't accidentally break something. Now this might seem like a trivial example. We didn't do a huge refactor, but I think you can see in a complicated system where there are lots of interdependencies and you want to go in and maybe move stuff around quite a bit, well, being able to prove that you didn't accidentally break something has a lot of value and can actually speed up your development process. Okay, so that is the first change. Now, I've got a few others that I want to go over. The next thing I want to do is I want to make this drink names list data-driven. And I've started this off by creating a table called drink menu that has a drink name and a price, and by loading our items, our drink menu items, into that table. So what we need to do is we're going to need to create a little class to manage that. So I'm going to go to my coffee shop lib, and I'm going to say add class, and we can call this one drink menu. And I think we'll need a little class here, a little data class for our drink menu item. So this will be public class drink menu item. And it'll have the name, and it'll also have a price. So there's our drink menu item. And then this class will be public, and it's static. And our method will be a list of drink menu items that we'll get. So, sorry, I need to say that this is public static drink menu item, get drink menu. And because we're doing test first development, we're going to throw a new not implemented exception. So what we're doing here is very simply extending the interface. We're going to have some new data, some new methods, maybe some new business rules. And so the very next thing we need to do is go to our test class, and we'll say add class, and we can call this drink menu tests. And in here, we're going to create a test fixture that exercises that method. Now, I don't think there's a lot of value in having you watch me type through all of that. So I'll pause the video, I'll type it all out, I'll show you when I'm done, and then we'll move on. Okay, so I think I've got these new tests and new code in place. Here are my drink menu tests, and there's only one. We're going to test getting the menu. So I call the get menu function. And in this case, I happen to know there are 5. So at least for now, I can verify that there are 5. And I also want to verify that each one of them is valid so that the drink name has a value and that price is greater than 0. That was a pretty simple test. And then here's the actual drink menu code. Again, it's very simple. We're going to open a SQL connection, query, and in this case, we're using the SQL data reader to simply read the result set and write it into the result and return the result. And I ran the test, and it works. The next thing I did is I went back to our coffee shop, and I made the place order method more data-driven. So before, you may recall, we had this static list of valid drink names. So now, place order is calling drink menu, get menu, and it's validating the input against that list. So it's saying, if not menu.any, and then we have our little predicate expression here where it's checking that the order drink name matches to a drink on the menu. So what this means is we've added a SQL call inside of every call to place order. So that might slow things down a little. And I'm grateful that we have a test performance test that will make sure that that didn't slow things down too much. So that was the change I made to coffee order. And then I went through, or to coffee shop. And then I went through the coffee shop tests and I made those data-driven also. So let me just initialize that to null so it knows. And I actually took advantage of the concept of the one-time setup to load the menu, because we have a whole bunch of tests in here that all need access to the menu, and they don't all need to query for it on their own. So in test fixture setup, we're going to go and grab the menu. And then in place order, we can do a loop now. So for each menu item in the menu, place an order for that menu item. That made that test a little stronger. And then in every other place where I needed a drink name, instead of hard coding latte, I picked just the first item off the menu, whichever that is, and I used that. You can see that throughout the tests. Now, the last thing I did was, I wanted to show this to you. This test for a drink name being too long, this is really now kind of redundant because we know we're validating against the list. So I took out the code in Coffee Shop that checks that condition explicitly, and we can take out that test too. So I think it all works now. We'll just run them again. And that was a little mix of adding something to our interface and then refactoring some existing code. And look, we still are passing our performance threshold. So that's good. Okay, I'd like to make one last change. I want to add a property here to our coffee order. And this is going to be a decimal for total price. And the idea behind this is that this is equal to coffee drink price times quantity. And we'll be using this perhaps a little bit later. So we need to update our tests. Let's go look at the tests. So if quantity is 1, we could just write a very simple test like this, where the menu item dot price equals the drink order dot total price. So that is true for drink orders where quantity is 1. But we really ought to be testing other quantities. So let's declare a decimal. And let us increment it like this. Quantity equals, and we can use our ternary operator. So if quantity is less than 5, then just set it to quantity plus plus, increment it. Otherwise, should be a question mark right there. Otherwise, let's set it equal to 1. So what'll happen here is it'll increment up to 4 and then it'll drop back to 1. And that way we don't ever go over our max quantity. And then we can set quantity to quantity and we can adjust this line of the test to include total price times quantity. I'm not going to implement the implementation code now. I just wanted to illustrate the interface change and the test change. And overall, I hope you've gotten a sense of how when you're changing your code, you kind of need to work back and forth and maintain the tests as you go. Sometimes the tests don't need to change at all in the case of a refactor, and sometimes they do need to change. The point is not to let your test library go stale on you. It does take a certain amount of discipline. You have to really commit to the idea. And then if you do, your test library becomes an enduring resource, which keeps your code quality high going into the future.